This lesson is for Unit 2, Lesson 7 on irrational numbers. Irrational numbers are numbers that when evaluated or calculated out, they never terminate, so the decimals don't stop, and the decimals are not repeating decimals. So for example, the square root of 2, if you actually calculate out the square root of 2, it goes on and on and on and on forever without ever repeating. And similarly, the number pi, for example, if you calculate out pi on your calculator, it's not just 3.14, it goes on and on and on forever. It's an infinite number. So irrational numbers are numbers that are like the square root of 2 and pi. They go on and on and on forever without ever stopping and without ever repeating. So to simplify rational expressions, going back to a few lessons ago with where we could break apart square roots, that's the process that we're going to be taking today for simplifying rational expressions. So you want to be thinking about what the perfect square factors are for each of these numbers and factoring it out that way. So if you think of the square root of 20, if I break that apart into two separate factors, thinking of with factor trees, this could be then the square root of 4 times the square root of 5. And square root of 4 is a perfect square. I'm able to evaluate that easily. So that would actually simplify to 2 times the square root of 5. Square root of 5 is not a perfect square. So our simplified answer for the square root of 20 would be 2 square root of 5. So you're trying to break that number apart into perfect square factors. And if you don't know your perfect square factors through 20, take a look at, if you just do a quick search online, you'll be able to find perfect square lists up to however many numbers you want. But it's helpful to know at least through the first 20 to know what, like 20 times 20 is 400, things like that. So it'll help you break those factors apart into perfect squares. A number, this is read as 2 times the square root of 72. So think of this already as 2 times the square root of 72. And we can actually break square root of 72 apart. If you think of perfect square factors again, and just doing a factor tree, 72, I know I can multiply 8 times 9. So you could think of this as 2 times the square root of 8 times the square root of 9. Well, square root of 9 is a perfect square, and 8 isn't a perfect square, but it has additional factors in there that we could pull apart. There's another perfect square number in there, so 2 times the square root of 2 times the square root of 4, because 2 times 4 is 8. So there's a perfect square, and then times the square root of 9, and then just simplifying the ones that actually evaluate out to be perfect squares. So square root of 4 is times 2, square root of 9 is times 3. So 2 times the square root of 2, and then multiplying all of your outside numbers. So 2 times 2, 2 times 2 is 4, times 3 is 12. So this would actually simplify to 12 times the square root of 2. You can also simplify rational expressions that are fractions. If you remember back at our earlier study of simplifying rational expressions, I could rewrite this so that it is actually the square root of 8 over the square root of 9. And we don't want rational expressions in our denominator, but the square root of 9 is a perfect square. In our numerator, 8 breaks down to perfect squares by multiplying the square root of 2 times the square root of 4. And the square root of 9 is a perfect square. That simplifies to actually 3. One more step, square root of 4 is a perfect square. It's 2. So we're left with 2 square root of 2 on the top all over 3, and that would be our answer. So you can break it apart into two separate square roots, evaluate them separately. Just make sure your denominator does not have a square root as part of the denominator. If it does, you'll have to multiply So for example, if I had 3 over the square root of 2, I would have to multiply the top and the bottom of this fraction by the square root of 2, because 2 times the square root of 2 creates the square root of 4, and that's a perfect square. On the top we'd have 3 square root of 2, so this then would actually reduce to 3 square root of 2 over 2, and then you don't have that square root in the denominator anymore. So make sure if your denominator has a square root, multiply by that square root so that it's a perfect square, and then make sure you multiply both the top and the bottom by that. Last one, combining our square roots lesson with this one. With combining rational expressions, you're like combining like terms. So you're looking to see if there's any terms that can be combined where the square root is the same, but make sure you simplify the square root first. So square root of 98, if I divide out a 2, this is the same as the square root of 2 times the square root of 49. Well, 49 is a perfect square, so this is actually the same as square root of 2 times 7, or 7 square root of 2. So we can actually replace that square root of 98 with that. So 3 times the square root of 2 plus 7 times the square root of 2. Now I can add the numbers in front, 3 plus 7, to get 10 square root of 2 for our answer.